Let's take a look now at what happens when two waves interfere with each other. We're going to talk about interference. So waves of a given frequency. Let's say that I've got these two waves. In fact, they might be different frequencies, but in this case, I'm going to have them the same frequency. Let's say that this wave over here is traveling in this direction, like that. And this wave over here is traveling in this direction, like that. All right, so let's move this one over here, and then let's take this one and move it over and see what happens when they collide. Well, they might end up in phase here, like that. So now I've got two waves the same. Well, what's going to actually happen, and I don't have it described here visually, is that the amplitude will double here because they reinforce each other and create a greater amplitude. However, if they arrive out of phase like this, now I have a crest here and a trough here, and the crest and the trough will cancel each other out, and you'll just get a straight line, a zero signal. You could actually do an experiment and see the same thing with a water tank. Let's say you take a tray of water and you start a wave generator on one end of the tray and another wave generator on the other end of the tray, and you make the waves out of phase, exactly 180 degrees out of phase with regard to each other. Well, what will happen is you'll have a nice smooth surface on the water. You won't see any wave. So this is what happens when I've got two radio signals going on at the same time, and they're bouncing around off the walls and they're echoing and they're hitting each other, and sometimes they may end up like this and cancel each other. Other times they may end up like this and reinforce each other, and you have mayhem and chaos. So when that happens, we have an issue with RFI, radio frequency interference, where I've got two different radios with intentional signals like this broadcasting at the same time, and the waves interfere with each other, and that can slow our transmission rate. It doesn't really slow the transmission rate, but in effect it does, because you have to keep retransmitting over and over and over in order to get the data out without interference, and so it tends to slow the speed of the connection or even cancel it altogether. Now, there is another kind of interference, and that is what we call EMI, electromechanical interference. So in that case, what I have is a machine, and this machine is producing it's producing these sine waves, but they're just all over the place. Sometimes the frequency is one, sometimes it's another. In other words, it's an array of frequencies, motors, microwaves, natural phenomena. These are not intentionally rated waves. These are from natural phenomena around us, and they may also interfere. So we have RFI, radio frequency interference, and EMI, or electromagnetic interference, or sometimes called electromechanical because they're machines, but electromagnetic interference is what it actually stands for. And it could be, say, a microwave oven or a baby monitor or an elevator motor that can create interference with our signals.